Hello everyone. So this is my discussion 8 post. So first we're going to look at galoots who care for their offspring. My sample size was 40. So we only have two options for this obviously. Um, there's galoots who do care for their offspring, which are represented by um, this column right here. Um, 1. And then, of course, galoots who do not care for their offspring, which is represented by this bin right here. So as we can see, there's more galoots that do not care for their offspring than galoots that do. It actually turns out to be about 3/4 of galoots do not care for their offspring, while only 1/4 do. So proportion is 25%. Standard deviation is 43%. And of course, the minimum is 0 and the maximum is 1, as those are our only two options. So the confidence interval for P. So what we're looking at here is the confidence interval says that we are 95% sure that the true mean for the galoot population is between 14%, which is represented on the table right here, and 36%. So this yellow line right here on this table. This math was done by Excel, thanks to the spreadsheet our professor gave us. So the hypothesis test for P. Step 1, the null hypothesis said that 50% of galoots would care for their offspring. And my hypothesis was that the number would actually be less than 50%. So we have more than 10 successes and failures in this. We're assuming it's less than 10% of the population of all galoots. That was never specified. And these are independent observations. So my proportion, as I said earlier, was 25%. So we're going to subtract that from the null hypothesis, which is 5/10 here, and that's going to come out to negative 0.25. Our random noise is simply the standard deviation, and to find the z-test statistic, we're just going to divide the difference right here of negative 0.25 divided by the random noise, or the standard deviation, and that's going to give us approximately negative 0.58. Step 4, our p-value, this was calculated by Excel as well, is going to be 0.0016. This is well under the significance threshold of 0.05. So this is, or the null hypothesis is rejected. So this is just a visualization of that and some of the data done on Excel. So the next thing we will look at is the galoot weight. Looking at this histogram, for the sake of this assignment, maybe if we really use our imagination, we can say it's nearly normal. So the mean is 12.4, which is going to fall in right this area. So I mean, the data is centered fairly well around the mean. The standard deviation is 4.42. So that means a majority of the galoots are going to fall between roughly 8 pounds and 16 pounds. The smallest galoot recorded was 3.8 pounds, and the biggest galoot recorded was 22.10 pounds. So moving on to the confidence intervals for this. Confidence interval spans from 11.22. This is the lower limit. And then the upper limit is 13.58. This is shown on this table right here by this gold bar. So what this is telling us is that 95, or the true mean of the weight of the glutes falls between 11.22 and 13.58 pounds. So the hypothesis test for this, the null hypothesis was 10. My hypothesis is that it's going to be greater than 10. As I said earlier, if we use our imaginations, we can justify that histogram being nearly normal. For the sake of this assignment, once again, we're going to assume it's less than 10% of the population, as I was never specified, and these are independent observations. Step 3, we're going to take the average I got from my study, subtract the null hypothesis, and get a difference of 2.4. This leaves us, to calculate the random noise, we're going to take 2.4 and divide that by the standard deviation of 40, which was our sample size of glutes. And that's going to come out to approximately 7/10. And then the Z statistic, this is calculated by taking the difference of 2.4 and dividing that by the random noise of 0.7, and this will give us 3 and 43 hundredths. Step 4, the p-value calculated by Excel of 0.0006. Once again, this is smaller than 0.05, which means that our null hypothesis is rejected once again. And this is another picture of what we just discussed. So the confidence interval results and the hypothesis testing. So for the weight of the glutes, the confidence interval was 11.22 and 13.58. The hypothesis or the null hypothesis was rejected. As for glutes that care for their offspring, a majority fell between, or the lower limit rather, was 14 hundredths and 36 hundredths, so it fell within that range. And once again, the hypothesis or the null hypothesis was rejected. So, comparing my data to my peers, I believe they'll be fairly similar. With a few minor differences, of course. They're not going to obviously get the same thing due to their sampling app randomizing the samples. But I believe that our results will be fairly similar, within the same ballpark overall. So that's my discussion 8 post. Thank you for watching.